Hi all, today we will discuss about the milling machine. Here this is a column and knee type of milling machine. Why it is called as column and knee type of milling machine is, here it resembles like a column, it resembles like a knee, and this is the column. So for example, if we sit like this and put a table on this, so this is our knees and this is our column and this is the table. So it resembles our knee and column. So that's why it is called as a knee and column type of milling machine. Now we shall see various parts of this knee and column type of milling machine. There are two types in this knee and column type. The first one is horizontal type of machine. Here the spindle axis is horizontal, so that the cutter is also mounted in the horizontal plane. And another one is vertical milling machine, in which the axis of the spindle is vertical. So here we have this horizontal type of milling machine. So we know that this milling machine is used for producing flat surfaces by using a multi-point cutter. So here this is the multi-point cutter which is mounted on a horizontal arbor. So as it rotates, the workpiece is allowed to move over the cutting tool so that the machine takes place and it produces flat surfaces. Unlike turning, which produces cylindrical surfaces, it produces flat surfaces. Now let us come to the parts. See here, the bottommost one is called as the bed or base, on which this vertical column is mounted, and this is called as knee, and this is called as saddle, on which a table is mounted, and this is the cross rail. Now let us discuss in detail about each and every component. So the bottom one is the base of the machine, which supports all the components of the machine, and in some machines it can be used for storing the lubricant, and on which a vertical column is mounted. So here this vertical column houses the driving mechanism for the tool. So here in this column electrical motors are provided which are used to drive the arbor, spindle and the cutting tool. And on the front side of the column there are certain guideways. See, these are the guideways on which this knee moves up and down by using this screw. See here, it can be moved like this. See, the screw is rotating and it is moving up and down like this. See, it is moving upwards and downwards like this. So here this knee moves over the guideways which guides the knee for its vertical movement, and on this knee again there are certain guideways on which the saddle is mounted. So this is that saddle which is moved perpendicular to the face of the column. So this is the face of the column and this saddle moves perpendicular to the face of the column, and it can be moved like this. See, now the saddle is moving backwards if I rotate in clockwise direction, and if I rotate in anti-clockwise direction it will move forward. So this is used to move the workpiece perpendicular to the column, and on the saddle there is a table provided. So here this is the table. So here this table can be moved longitudinally like this. See here, this table is provided with the T slots like this. So these are the T slots whose cross section is T like this. See here, it looks like a T. Okay. Now on this T slots we can mount our work holding devices. See, for example, we can place a machine vise, so that a workpiece can be handled that, and then the workpiece is moved. So here the workpiece can be moved by using the table itself. So here the table can be given movements in 3 directions. The one is vertical direction by moving this column, by moving the knee, you can move it upwards or downwards, and it can be given longitudinal motion also by moving the table in this direction, or it can be moved in lateral direction also by moving the saddle. So 3 directional movement is possible for the workpiece. And here in this machine, there is no machine vice is provided. Instead of that, there is an indexing mechanism which is used for cutting the gears. And here, this is the vertical horizontal cross rail on which this support is provided for the arbor, and this is called as arbor. And inside there is a spindle which is driven by the motor inside the column, and this spindle is connected to the arbor on which this multi-point cutting tool is mounted. So this is the cutting tool. So here it consists of number of cutting points. So that's why this is called as a multi-point cutting tool. So this is briefly about the milling machine. So here this is a horizontal milling machine. And here if you observe, there are some graduations on the saddle. So that indicates that this table can be rotated. So that rotation can be seen from the top view. So if the table can be rotated, then that is called as universal milling machine. If there is no rotary motion for the table is provided, that is simply a horizontal milling machine. So in a horizontal milling machine, only there are 3 directional motion is possible for the workpiece. That is, one is 2 in horizontal directions like this, and 1 is in vertical direction. But in case of universal milling machine, there is a swiveling motion is also possible in machining operations. So this is about the milling. Thank you.